Hi, everyone, and welcome back. Today, we are starting a new Leetcode series, and more precisely, we are looking at the dynamic programming one, which is a very common subject, especially when we talk about interview questions. Actually, I think dynamic programming can be found in almost every interview on this planet, especially in high-tech companies, the FANG group, and almost whichever job you want to take regarding software engineering. So without further ado, we will join this dynamic programming on Leetcode. And oh, we also have to press start. Yeah, obviously. And apparently we still have to enter manually. So when you log into Leetcode, this should be the main frame. I would presumably get me directly into the study plan, but it just appears ongoing here. So when we enter here, we see that we start off with something very simple with the Fibonacci sequence. And taking a look at the problems, I think it would be much better to start with the second one so that we get the basics done better, and then I can easier, whichever you say, all right, so that we can easier cover the other ones. So I want to solve the second one first so that I can use something from this explanation to show you the first one much easier visually. Okay, so we are starting off this problem. It's apparently the problem 509, Fibonacci number. Very easy. We'll read the problem very quickly. So the Fibonacci numbers commonly denoted f of n form of sequence called the Fibonacci sequence, such that each number is the sum of the two preceding ones starting from 0 and 1. Most of you might already be familiar with it. Don't worry, we'll get to more complicated things really quickly. But for now on, I'm going to try to code as simply as possible in C++. If you want to follow along in Java or Python or any other programming language, feel free. The idea is the same. You just have to adapt the solution to your programming language. So the theory is similar. You should have no issue doing that. So in case you don't know how Fibonacci number works, it's like this. So we are starting off from 0 and 1. And then the following number is the sum of the previous two. So right now, if we add 0 and 1, we get 1. Now, if we add 1 and 1, we get 2, and so on. We adding 1 and 2, we get 3, 2 and 3, and we got 5, 3 and 5, we got 8, 5, 8, 13. Now I think it's 21, 34, and so on. I think you got the idea, right? So whichever number you want, it is the sum of the previous two numbers. All right, and also this is f or fib of 0, of index 1, of index 2, index 3, and so on. Just so that we can easier also see the index. So which so this number, which index does it have inside of the fib vector or array if you want. 6, and let's also fill this out, 7. All right. Now, the idea, writing the equation one more time. So f of I is equal to f of I minus 1 plus Fibonacci of I minus 2. Right? So exactly what we have spoken before. If we want to find out which number stands on the 7th spot of this array, we add the previous one and the previous of the previous one, right? So the previous two numbers. All right, now I think you got the idea. So how do we implement this into code? So it tells us that f of 0 is 0, f of 1 is 1. It also gives us this equation that we run here for the index greater than 1. Yes, because the first two elements are already given. And given n, we should calculate the nth element of the Fibonacci sequence. All right, so here it might ask for 7, so n can be equal to 7. And in this case, we have to return 13. all right, because 13 is the number that stands on this. It's the 7th number, actually the 8th, because we are starting from 0 in the Fibonacci sequence. Now, coding this is extremely easy, and we will just follow this very small principle in finding out what our number is. So we are starting from 0 and 1. And this is actually our very first edge case. If we have 0 or 1, we have to directly return them. So first, if n is equal to 0, we will directly return 0. If n is equal to 1, we return 1. I don't have to use here an else because in case this doesn't run, we will just continue running the code because that's how return works. So we can just directly move on. And right now I can create a variable, let's say an integer called behind 1. So one element behind our current element, which is 1, and behind 2 is equal to 0. And we also need a current 1. All right, so what do I want to do with these variables is that when I'm traversing here, because again, I'm starting from 0 and 1. Okay, so right now this is my starting point inside of the code. And right now, whenever I want to compute the following item, which is the current item as I called it, all right, I'm going to do this by adding behind 1 and behind 2. So the two previous numbers behind current. And that's why I always have to remember those. So I'm going to call this behind 2 because it's 2 elements behind the current one. And this is going to be behind 1. And whenever I use them to compute current, okay, which is our current variable, let me just delete that very quickly. Right now, 0 plus 1 it will be equal to 1. And right now, I'll have to make some changes. So because right now we computed our current, and maybe we didn't reach the endpoint. So n equal to 7. So right now we have to swap the variables. We have to move b1 here. So this would be the new b1. Actually, starting from current, we will move current here. Now our question mark, let's say, will be, I didn't write it properly. So current will be the following item, which we don't know yet. B1 will become this one, and B2 will become this one. Okay, so as we can see, after every iteration, we have to move one element in front with all of our variables. Very important to keep in mind. So following this pattern, we come back here, and right now we are not being given 0. Okay, as you can see, we have here the constraints. So n is between 0 and 30. This is why we have integers here, so just small numbers. We are not having 0, we are not having 1, but we are having a greater number or equal to 2. So for the purpose of this, we can either use a for loop in which we can declare an index equal to 2. Index has to be lower or equal to n, and we increment the index after every iteration. There's also an easier way in which you can solve the issue. We can just, for example, instead of this for loop, we can just write while n minus minus. But considering that this is an easy problem, I'm going to leave the for loop for now so that you can find it easier to follow each item. And in case you get stuck, you can always see out the current item and the index as well. I'm going to show you in a second what I mean by that. So firstly, we are having a new iteration. All right, we don't know who the new element is. So we have to firstly compute the current element. Now, how do we do that? Well, current is equal to behind 1 plus behind 2, like this, nice and easy. And after we finish this, so we computed our newly created element. Here we have a 1. Okay, so we computed current, which is 1 plus 1. So we have a 2 here. And right now we have to move these variables in front. So after we computed current, for the next iteration, behind 1 will be our actual current, okay? Because when we enter the next iteration, current will be pointing, actually will be represented by the following item. So B1 has to move in front, and which element it's going to be B1 at the following iteration? Well, it's the current of the actual iteration right now. This is why behind 1 here will be equal to current, and behind 2 obviously is going to be equal to behind 1. Okay, because we are moving behind 1 here and behind 2 here. Now, if you write the code like this, there's a slight issue, because it might seem correct to you, but after you write this one, so you compute current, okay, you move behind 1 to current for the following iteration. Okay, so right now we have finished what we have to do for the current item, and we are preparing for the following one. But when we are going with behind 1 here, behind 1 takes the value of 2, all right? So behind 1 goes here, all right? And right now when we run behind 2 is equal to behind 1, well, behind 2 will not go here because behind 1 is pointing towards this 2 element, has this value. So behind 2 is also going to be here. Big problem. And this is why right here we have to do it the other way around. So firstly, we have to update behind 2 and then behind 1. Why is that? Well, let's follow the code one more time. Current is equal to behind 1 plus behind 2. So it will be equal to 2. Okay. And now we want to move behind 2 here. So behind 2 will get the value to behind 1. All right, seems all right. And now we want to move behind 1 to the actual current to prepare the layout for the following iteration. So that right now the current of the following iteration will be equal to this behind 1 plus this behind 2. All right. And well, that's it, because right now we will continue doing this iteration up until this index will have reached the number n. And obviously we are starting from 2 because for the first 2 items we have already considered them edge cases and we have covered beforehand. So this is why we are starting from 2. We are starting computing from the second number, and after after this loop is finished, we just have to return current or minus 1. Let's run test cases. What? Okay, so now that I have that figured, let's run the code. And apparently both of actually all of them runs properly. So we have not been making any mistake regarding the indexing of this problem. Let's also submit. In the previous version of Leetcode, you had those buttons right here. So submitting the code, and well, apparently we have beat 100% of people. And regarding memory, yeah, we declared a few integers here, but is no issue. Also, if your code doesn't exactly beat the exact same number as mine does, it takes into account a lot of stuff. So you shouldn't take into account the runtime and even the memory that much, because at most interview questions, they don't really care about memory. So you can allocate pretty much. We don't have any issue with space complexity. We only mostly care about time complexity. All right. And also on Leetcode, keep in mind at every single run, you might get different run times. Sometimes you might get a better one or a worse one, depending on your internet connection, depending on the server, depending on a lot of stuff. So it's not only your code involved. If you want to test your code, it should be better if you do a benchmark of your own, which we will be covering in another video. And this should be the Fibonacci sequence in a nutshell for now. Thank you very much for watching. And in the following one, we'll be covering a more elegant approach, let's say, to this very simple and trivial problem. Thank you for watching. See you there. Bye.